We saw how this BGP is so important to run between autonomous systems. So within our organization, we prefer a IGP protocol. We prefer a protocol that has got simple metric like cost based on bandwidth or delay. So within an organization, we actually prefer IGP protocol like OSPF or EIGRP or RIP or ISX. But between autonomous systems, when we have an autonomous system as a transit autonomous system, or when we have some policies in path selection, when we are having multi-homing scenario, we always prefer BGP. Why? Only BGP can have can provide you the options to apply the policy that you expect from the path selection. Using attributes that we see in BGP, we can easily set policies. Without BGP, doing such policy-based path selection, it is tough. It is possible, but it is tough. See, you might have heard about tagging. Earlier days, we used to tag traffic. Tagging in EIGRP, tagging in OSPF. Nowadays, we don't do those things because we got a better way to do. Early days, we used to tag, and then we used to identify the packets with the tag. We identify the updates with the tag, and when the tag matches, we provide some special service, right? So just one tag itself was even that important. But today BGP can carry multiple tags. We don't call it as tags, we call it as attributes. And different attributes here have got different meaning. Whichever suits your expectation, we tune that attribute. So this is more advanced tagging. Here in BGP, the tagging is called as community values, which you'll be seeing in the later days. Not now, it's too early for getting into community. So let us now focus on what we learned yesterday. We were learning like BGP has got 3 tables: BGP, neighbor, and routing. 3 tables: BGP table, neighbor table, and routing table. Neighbor table will have those peers. We call neighbor as peer here, BGP peers. Neighbor, basically, with whom TCP 3-way handshake is successfully done, with whom BGP packets successfully got negotiated. So the 3 tables we are going to see in this lab. After that, I'll also capture packet between 2 routers and show you the different message types that BGP shares. I should say different packet types. Like soon after 3-way handshake, you'll be seeing open message. We learned earlier in the previous class that open message will carry the router ID and the hold time of the sending router. The default hold time in BGP is 180 seconds. 180 seconds is the hold time. There is a periodic keep alive which is sent every 60 seconds, and there is a hold time. If keep alive is not coming for 3 cycles, then the neighbor will be considered down. The neighbor will be removed from the neighbor table. That is what called as hold time. So this hold time and the router ID is shared. Actually speaking, this hold time need not to match with the neighbor. Not really necessary to match. But it is sent in the periodic keep alive packet. Sorry, open message. First is open message. The keep alive packet is next, which is sent every 60 seconds. Updates are sent whenever there is a change. Initially, updates will be shared in between all the routers. Later on, it won't send the updates. Only when there is change in the topology or network, the update will be sent. Changes like attribute change, policy change in reaching a destination. At last, the notification message. Notification message is a message that is generated only when there is a break in the wire, when there is an error detected between 2 neighbors. Those things we are going to see now. For that, I have taken 3 router with 2 router on the right under one autonomous system called 20, 1 router on the left with the autonomous system number called 10. Here I'm going to show you EBGP, IBGP differences, and I'm going to show you how the packet looks like. The IBGP packet looks like, and how it differs from EBGP packet, where it differs from EBGP packet. So we're going to have a close look into the packets. Before I get into more detail, I would like to also add something which I should have covered in the previous class. This is TCP based protocol, we know it. But I also need to say, when I say TCP based protocol, I should say neighbors cannot be dynamically discovered. Because it is TCP based protocol, you need to provide the neighbor IP address to which BGP can negotiate and bring up the neighbor. So this point I should have added in the previous class. You will be seeing me configuring neighbors manually. Yeah, neighbors need to be manually configured. Not only that, when we configure a neighbor, we need to make sure the neighbor is reachable. The neighbor address is reachable. Why? Because it's a TCP based protocol. It will send the packet to that address, and if that address is not available, the neighbor cannot come up. So the neighbor that you configure, the address that you give as a neighbor address, should be a pingable address. So what I'm going to do in our example here is I'm going to form neighbor between R1 and R2 using this address. So I'll go to router 1 and say your neighbor is 10.12.02. See, it is easy to reach this address. There is no routing needed. Why? because it's directly connected. So I'll say this is your BGP neighbor with whom you want to associate, with whom you want to form EBGP. Likewise, I'll go to router 2 and say your neighbor is 10.12.0.1. See, simply saying neighbor is not enough. You also need to add the autonomous system to which the neighbor belongs to. So I will say neighbor 10.12.0.2 remote autonomous system. What is the autonomous system of 10.12.0.2? It's 20. Likewise, here we will say neighbor 10.12.0.1 remote autonomous system 10. If you just give this one, now what this computer will do, this router will do, it will use its exit interface that connects to 10.12.0.1. What is the exit interface that R2 will use to talk to the neighbor? Can someone tell what will be the exit interface IP address R2 will use to talk to R1? Will it use sender 23.0.2 or sender 12.0.2? Which one? You are in mute, you need to unmute and say. Yeah, exactly. So this is the direction where the neighbor 10.12.0.1 resides. So it will say, I'll source it with 10.12.0.2 and I'll try to negotiate with my neighbor who is 10.12.0.1. See, based on what you configure as a neighbor address, your destination will vary. I said neighbor is 10.12.0.1, so that becomes destination of the packet. Now, when this packet reaches R1, R1 will not simply accept it. R1 will say, wait a minute, who are you? From where are you coming? I'm coming from 10.12.0.2. Okay, let me check my neighbor list. Yes, you are my neighbor. I accept you now because you are configured as a neighbor for me. You see, R1 accepts R2 as a neighbor only when the source address of the R2 matches with the neighbor address configured on R1. If this match don't happen, no neighborship. The three-way handshake will not even finish complete. For the three-way handshake to complete, this both the side, sorry. Now here what we see is the source address of the neighbor's packet should match with the neighbor list in the local router. So what I was talking is, for the three-way handshake to be successful, your BGP configuration need to be correct. What is the connection between three-way handshake and the BGP packet? Because it's a TCP protocol that uses TCP, before sending open message, I told you the three-way handshake will happen. Now when it sends the three-way handshake, it is sending with this source address. It is sending what? A sync packet. And router 2 receives the packet. If router 1 receives the packet from router 2, if router 1 finds router 2's address in its neighbor statement, only then router 1 will send SYN plus acknowledgement. Otherwise, it will simply send only acknowledgement. So only two-way handshake will happen, three-way will not happen. because they're going to use TCP 179. So that it can go to router 1 and say, hey BGP. That's how. Hey BGP. How router 1 knows that it's saying hey BGP, hi BGP, 179. Router 2 comes to router 1 and say, I want to talk to 179. Okay, BGP says, yes, it's me. From where are you coming? 10, 12, 02. Okay, let me check with my neighbor list. Yes, you are in. You are my neighbor. So I'm also now interested in forming neighbor with you. Let me send SYN plus ACK. And for the SYN, there will be a third handshake ACK. This is what the three-way handshake, right? So if the neighbor IP address is not properly configured, the three-way handshake also won't happen. I'm going to show you this. I'm on router 1, and I'm going to run BGP between R1 and R2. You see, router BGP, autonomous system number 10. It says BGP could not pick router ID. You know why? I need to have at least one IP address on the router so that it can dynamically pick the router ID. If not, you have to give router ID manually. So let me give BGP router ID 1.1. So to give an address as a router ID, that need not to be there available on any interface. It can be any 32-bit divided into 4 octet using decimal, using 3 decimals. Next. Actually speaking, I should first configure IP addresses. So let me configure interface G1/0. Now set IP address 10.12.0.1.255.255.0.0. Now what I can do is I can go back to router BGP 10 and I'll say your neighbor is 10.12.0.2 and this neighbor belongs to autonomous system 20. That's all actually you need to configure. See, it's not easy, it's not difficult, right? It's very easy. Neighbor, not network, neighbor. And now if you want to verify this, you remember I was telling you there will be 3 tables for BGP. One is neighbor table, the other one is BGP table, and the other one is routing table. Neighbor table, to see, we need to type this command show IPBGP summary. There is also a command called neighbor that will show a big page of info. So we always use, see, it shows big page of information. So we always try to keep a simple table. See, it says neighbor is not established. It is in idle state. We'll talk about the idle state in some time, but as of now, what I want to say is it shows idle state because the address don't exist. Which address? 10.12.0.1, sorry, 10.12.0.2. The neighbor that we have configured is 10.12.0.2. That doesn't exist. This address doesn't exist anywhere in the topology. That's why it is idle. Now let's go to router 2 and configure IP address followed by BGP. Router BGP 20. What did I say here? Did I say, okay, 10, that's right. Router 1 is 10. Router 2 is 20. And again, it says you don't have any IP address, so I cannot pick a router ID. I'll say it's okay, I'll give you, don't worry, BGP router ID 2.2.2.2. And let's configure the interfaces. Interface G1/0. No shit. IP address 10.12.0.2. Right, and then router BGP 20. Neighbor is 10.12.0.1. Remote AS is 10. Now I'm expecting neighbor to come up. It is. See, it's here. Neighbor has come up. But I promised you that I'll show you packet capture. Yes, I'm going to show you that. But before that, I want to show you something here in the command line. That's why I did not start the Wireshark. The thing that I want to show you is the tables. Show IP BGP neighbor will show you big page of info. So to see the neighbor in a small table, you can type show IP BGP summary. It shows that this is what the neighbor in whom so far 5 packet has been sent and received, and this neighbor belongs to autonomous system 10, whereas my local autonomous system is 20. My local identification is 22222. That's the router ID. Table version. Okay, now for last 56 seconds, now it might be more than that. For last 1 minute and 32 seconds, the neighbor state is up. If it is not up, it will show you here something like idle, active. If it shows some number like this, it means good. And here, usually it shows never here. If neighbor is not formed, it will show never. And here it will show idle or active if the neighbor is not established. So for example, I'm going to interface G2/0. I put an IP address 10.23.0.2, 255.255.0.0, and I'm trying to form an IBGP with R3. So I say again router BGP 20, neighbor 10.23.0.3. See, even for IBGP, the command is same, remote AS. Even though the AS is not remote, we have to say remote AS. But when you put 20 here, local is 20, neighbor is also 20, which means this neighbor is not an eBGP, it's the same autonomous system 20. The neighbor is an IBGP. That's how it understands. Enter. Now if I type the same command, show IP BGP summary, you can see this neighbor has never come up. So far no packet sent and received. And this neighbor belongs to local autonomous system. See, local is 20, is also means IBGP, but never come up. It is in an idle state. See, instead of showing idle or active or something like that, it shows 0. What does that 0 mean? It means prefix received from this neighbor is none. It's 0. Because we have not advertised any network from R1. Because you didn't advertise any network, it says we are just neighbors, that's all. He did not share me anything so far. You can also see the same thing on R1. Show IPBGP summary. This also says I am having neighborship with him for last 4 minutes and 19 seconds, but so far nothing received from, sorry. But so far nothing received from him. So far nothing received. Let us make things interesting now. I'll go to R1 and advertise a network. Okay, I'm in R1. Let's add a loopback interface. Interface loopback 11, IP address 11.11.11.11, mask, sorry. Because it's a loopback interface, I'm masking it with all 4 octave. Because loopback interface will not be connecting to any other interface, means any other devices, so there is no need for more than one address on that virtual circuit. You cannot connect any physical device, so you can mask it with /32. That's what I did. Router BGP 10, I'm planning to advertise this so that R2 can ping this address. I say network 11.11.11.11. Very important thing that you should know is, if you're advertising a classless network, is it classful or classless? /32 is of course classless. You're right. So I have to put the mask command and specify the exact mask on the interface. Yes. Sir, 11 is class A. For class, so for class A it is 255.0.0.0. I'm using /32. It is not classful, it is classless. It is opposite of classful, no? It is classless. It is not class, it is not class A now or B or C, it is classless. So whenever you are having classless subnet, you must match with the subnet when you advertise. You must match with the subnet that you defined under the interface when you advertise. If the match don't happen, BGP will not advertise. That is how many people will teach you. I was also teaching like that only, but I want to change my version. Let me have my own way of saying this. If your interface is having /32, your routing table will also have only /32 for 11 network. Whatever is in the routing table only can be advertised. So try to match with what you have in the routing table so that BGP will advertise it. Boom. Whatever is seen in the routing table only can be advertised. Not only BGP, any protocol. Because I said /32 on the loopback interface, routing table is going to have only /32. So if you want to advertise that 11 network, you need to put that /32 so that BGP will look into the routing table and there will be a match found in the routing table. It will take that network and it will advertise it. This is the proper way of teaching. Why I should match with the mask. Let me now go and verify. I was telling you there are 3 tables, right? The first table we already saw, which is a neighbor table. The command was show IP BGP summary. See, we have not learned any prefix from this neighbor, so it is 0. But we are advertising the network from here, right? 11 network. That you will see when you type show IP BGP. Show IP BGP is the command that will show you BGP forwarding database. In this forwarding database, you will see the network that we advertise. Not only that, you'll see the network that was advertised, that is learned from the neighbor. For us, in our scenario, we have not advertised anything on the neighbor router. So you don't see anything from the neighbor. You see only your own network with the next stop 000. Why 000? because it is locally origined. Now, I would like to take you to router 2 and show you one more time the same command, show IP BGP summary. Earlier it was 0 here, but now it is 1. What does this 1 signify? It says that I have received one prefix from that 10.12.01. I have received one prefix from this neighbor 10.12.01. That's the meaning. I have received one prefix from this neighbor. What is that one prefix? For that, you need to type this command. Same command what I showed you in the second command that I showed you on router 1, show IP BGP. Just cut the summary and type show IP BGP. It shows that a network called 11 is advertised by next hop, which is 10.12.01, and it belongs to the autonomous system 10. You see, it's a path vector routing protocol. I was teaching you yesterday. It shows the AS path. It shows the autonomous system path from where the network is originated and through which autonomous system it reaches here. Here we don't have too many autonomous systems. It shows 10, it means this network 11, 11, 11, 11 actually originated from autonomous system 10. So this is BGP table. So far I have shown you two tables. The other table is the routing table. Show IP route BGP. It shows that from BGP update, the routing table have learned this network from this gateway, means then this is the next hop. And you see the administrative distance. The administrative distance of EBGP is, see the relationship that you have between R1 and R2 is EBGP. The administrative distance of EBGP in Cisco is 20. Whereas for IBGP it is 200. Listen. For EBGP, what is EBGP? The neighbor between two different autonomous systems. R1 and R2 is EBGP. What is R2 and R3? Sheikh. What is R2, R3? IBGP. Exactly. Exactly. So for IBGP, if IBGP router learns the route, the administrative distance will be 200. 200. But for EBGP, 20. This is only for Cisco. For Juniper, both for EBGP and IBGP, what? How come possible? Why means we don't give more preference to BGP internally. Internally, we prefer IGP protocols like OSPF, EIGRP, RIP. See, BGP is border gateway protocol, no? It should be between border only, no? We prefer BGP routes only between borders. Within the autonomous system, when you run BGP, we give second importance. If the same BGP advertised route is given by OSPF, we will prefer OSPF than BGP because internally we will like only IGP protocol. Internally we don't want BGP. We don't have policies much like what we have in between the borders. That's why it is 200. But Sheikh, you are a genius. You asked the right question. Why? But Cisco want to show that they are extraordinary. They want to show that they are different from others. But Juniper, if you see Juniper, for both EBGP and IBGP, the administrative distance is same, 200. 200 or 250, something like that, same. In Juniper, they don't differentiate with the administrative distance with eBGP and iBGP. It is the same. Now, so I have shown you three tables. It's time for us to capture packet and see. So let me do one thing. I'll just remove BGP on R1. I'll remove BGP on R1. No, or I'll do one thing. I'll shut down the interface G1/0 on R1. Shut down. I have shut down the interface, and I'll also go to R1. I'll clear BGP. This is the command to refresh BGP. Clear IPBGP star soft or star. Clear IPBGP star. What this will do is it will reset neighbor. Now, if you type show IP route BGP, there is no route. Show IP BGP, no route. Show IP BGP summary. The neighbor is in an active state, meaning it is trying to find the neighbor. Because I have shut down the interface, it has the route in the routing table. Router 2 has got route, but when it tries to talk to 10.12.01, it don't know where is the 10.12.01. See, it has gone to idle state. Idle means it looks into the routing table. Active means it is sending the packet, but no luck. The neighbor is not forming because we have shut down the other side. So what I'll do now is, for your better clarity, I'll say router BGP 20. I'll even remove the neighbor. No neighbor 10.12.01 completely. And then I will start the Wireshark. And now what I'm going to do is I'm going to finish configuring this BGP here. Neighbor 10.12.0.1, remote AS is 10, boom. That's all. Now, let us see if any packet is coming. No packet because line protocol is down. You see, router 2 is trying to send packet to 10.12.0.1, but it is not successful. So TCP, if acknowledgement is not coming, it will retransmit. See, it is keep on retransmitting, but no luck because the other side is not configured. And I want to see here, TCP is using port number 179. Why? On behalf of BGP, this three-way handshake is going now on behalf of BGP. That's why the port number is 179. And also I want you to notice here, the time to leave of this packet will be 1. The TTL of this BGP packet, eBGP packet will be 1. Now let me go to R1 and unshut the interface. As the link comes up, now you'll see, wonderful. Let me stop the capture now. Look, the three-way handshake is successful. See, SYN, SYNAC, ACK. Three-way handshake is successful. Followed by open message. See, router 2 is sending an open message to router 1 as a unicast. Let's open the open message. See, it's an open message. And what you see here is the router ID of the sender, the whole time of the sender, the autonomous system which he belonged to, and some parameters. What it is capable of. It is capable of MPBGP. These are all again, not, it's too much now. When we learn MPLS, we may need this. So open message is going in between two routers, followed by the keep alive message. The keep alives are sent every 60 seconds. And then update message, listen. Update is going from router 1 to router 2. See, BGP update message, path attribute. Look at this. It says your next stop is 10.12.0.1. The AS number is 10. IGP means advertised. This is not OSPF or EIGRP. Under BGP, if you see IGP, it means BGP's own network. And I'm trying to show you what network. It is 11 network. These are all it is talking about the 11 network that we have advertised. This is the one. See, this is very important place. What you see is very important. Why BGP is too heavy? It is not only advertising the network 11, 11, 11, 11. It also says to reach this network, this is the AS number from where it is coming. This is the gateway, and it is originated from BGP. It is not redistributed. It is advertised, and all these attributes, it is attached. You are having only one network here. When you have 100 network, then you will have 100 set of network layer reachability information sent and received. So the updates are sent and received in between these routers, and then followed by they keep sending the three-way handshake once in a while. The three-way handshake is successful. Now the second check is going between router 1 and router 2, the three-way handshake. Boom. So this is what I was trying to show you. The message types. We saw like after three-way handshake, open message, followed by that we saw keep alive. After that we saw update. Notification will be sent only when there is an error. We did not create any error. We did not see any notification there. Let me stop this debug completely. Yes, please. No. In between the open and the update. In between the open and the update, there is something called open confirm. As soon as open confirm comes, they form neighbor. And then only the keep alive will go. After keep alive, the updates will go. So updates are sent only to the established neighbor. Sorry, yes, go ahead. First the TCP handshake. Followed by open message, and then open confirm will be sent. That's the state actually. When I get the reply for the open message, it is called open confirm, which means the neighbor is established. And then updates will be shared with the established neighbor. Updates cannot be shared with neighbor, with someone which is not a neighbor. Yeah, so you can see here between R1 and R2, the neighbor state is established, and the neighbor's router ID is this, and then open message sent and received, and keep alives are sent this many and received. And then I would like to show you this TTL. I showed you there the capture TTL will be 1 for eBGP. And I also want to show you the keep alives in the whole time here. The keep alives are sent every 60 seconds in Cisco. Every vendor has got different timer for this. It doesn't need to match. So if you're running BGP between Juniper and Cisco, their clock is different, the timers are different, but still they can form neighbor. The timer doesn't need to match. So we have seen how to form eBGP. Let's form iBGP now. On R3, I'll configure the IP address, router BGP 20, neighbor 10.23.0.2, remote AS is 20. And you're going to see, I have to put some, okay, yeah, interface limit 0, IP address, I'll say 3330. This will be dynamically picked as a router ID. So on this router, I did not configure router ID, but you will see that fixed dynamically from the loop. Now, router BGP 20. I'll say neighbor is 10.23.0. Remote AS 20 only. 20 is iBGP. Now this neighborship will happen now. I'm expecting a log. Before that, let me try pinging 10.12.2. The ping should happen. No? Okay, maybe the other side is down. Oh, I'm putting wrong address. 23.2. What did I configure locally? I put 12.2. Neighbor is 12.2. That is wrong. Neighbor is not 12.2. Router BGP 20. Neighbor, I remove this. Neighbor is 10.23.0.2. Remote AS is 20. Ping 10.23.0.2. Not pinging. What address did I give here? What address? What address? I did not give any address. That's the problem. I just gave only the loopback. Interface G1/0, no share, IP address 10.23.0.3, 255.2. All right. Now neighbor will come up, has come up, and you can see show IP BGP summary. You got a neighbor. The neighbor is up. You also learned the prefix, and that prefix is coming from where? Router 1. See, show IP BGP. This is the prefix you are learning, and it comes from router 1. This is router 1's address. eBGP address is carried into iBGP. BGP will not change its next hop. We'll talk about that in detail in coming class. That's the next hop behavior. And you see the AS path. It says this network actually originated from autonomous system 10. You see, BGP is an autonomous system by autonomous system routing protocol. So by default, the next hop will not be the immediate router if it is iBGP. The next hop will be always the IP address of the eBGP router. 10.12.0.1 is eBGP for autonomous system 20. All right, I do not want to get into that area now. So what I want to show you is TTL value. I showed you the TTL for EBGP is 1, but the TTL for IBGP is 255. For this reason, the IBGP neighbor do not have to be directly connected. EBGP neighbor should be connected directly because the TTL is 1. I captured and showed you. I also showed you in the show command. Whereas for IBGP, the TTL is 255, so the neighbor can be even 200 hops away. That doesn't matter. As long as the reachability is there, pinging is there, you can form neighbor. Right, so here today what we have seen is basic configuration of BGP. And we also saw the message types. We also saw the difference in EBGP and IBGP output. So tomorrow we'll go back to our theory class. We'll learn more like next up behavior, next up self command, forming BGP between two loopback interface address instead of physical, using the update source command, and so on. Do you have any questions before we close? Yes. Yes. BGP never uses any metric. No bandwidth, no delay, no reliability, nothing. BGP uses only attributes. We have not gone to that portion. BGP uses something called attribute. That's all I have covered. You are not gone. Oh, see, yesterday class is available as a video. I have sent you the link and you also acknowledged it. Kindly go through this video. That is that much only I have covered. So today is the continuation of previous class. So when we are regular in this class, we will not have any problem. This